Hello everyone. Today we'll be looking at the topic stoichiometry. It is from chemistry. Now, what is stoichiometry? Stoichiometry is defined as the mole ratio to which reactants combine to form products. I go again. It is the mole ratio to which reactants combine to form what? Products. What I mean? If in the formation of water, you know molecule of hydrogen reacts with molecule of what? Oxygen to form what? Water that we know, which is what? H2 what? O. Does it make sense? Since as in form this chemical equation, we need to balance the equation. Now, in balancing chemical equation, you first of all balance the hydrogen before you balance what? Oxygen. Does it make sense? Now, at the reactant side, what's in how many atoms of hydrogen do we have? We have two. In the product side, we have two. So hydrogen is balanced, right? Now, at the reactant side, what's the atom of hydrogen? How many atoms of hydrogen do we have? Two. Why oxygen is what? One. Is oxygen balanced? No. So since oxygen here is two and oxygen here is one, we need to put what? Don't come and put two here. We don't change the subscript. We only change the number of moles during balancing. Is it clear? So we put two here now. Oxygen is balanced, right? Because that two times that initial one, two times one, oxygen is balanced. But when we put two immediately, hydrogen is now four here. Two times two, hydrogen is now four, but hydrogen here is still two. So hydrogen is not balanced. Since we balance oxygen, oxygen is correct, but hydrogen became what? Unbalanced. So we need to put two here. Can you see it? Two times two, four, right? Two times two, four. So hydrogen and oxygen are balanced. So watch out. Watch what we mean by stoichiometry in this chemical equation. It tells you that two moles, two moles of what? Hydrogen, of hydrogen gas will react with what? One mole of what? Oxygen gas to form what? Two moles of what? Water. Now, normally on a normal circumstance, the stoichiometry that we can see here, that for this reactant to combine to form what? This product water, that normally two moles of hydrogen is meant to react with what? One mole of what? Oxygen. That's why I say that stoichiometry is the mole ratio. That's 2:1. That's hydrogen is to what? Oxygen. The mole ratio to which reactants do what? Combine to to form what? Product. Does it make sense? The mole ratio to which hydrogen and oxygen combine to form water. That's what we mean by what? Stoichiometry. Does it make sense? Now let's use another reaction. If I have something like the Haber process, the industrial preparation of ammonia. If hydrogen gas reacts with what? Nitrogen gas to form what? Ammonia. Now, this reaction is not balanced, right? But when hydrogen gas react with ammonia, it's meant to form ammonia. Now, hydrogen gas, how many atoms of hydrogen do we have here? It's two, right? How many atoms of hydrogen do we have here? Three, right? Are they balanced? No, hydrogen is not balanced. So we need to balance hydrogen. Now, if I put two here on this ammonia, two times three, hydrogen becomes six, right? But here, hydrogen is still two. For me to make them to be sixes, I have to put three here. Three times two, hydrogen has become six. So hydrogen, balanced. Now is nitrogen balanced? Nitrogen, how many atoms? I have two. Nitrogen, how many atoms? Recall that there is an invisible one here. Two times one is two, right? So nitrogen is still balanced. So this chemical equation for the Haber process is what? Balance, right? So the stoichiometry that we're talking about, now the reactant, look at them. Now the ratio H, hydrogen gas is to nitrogen gas to form ammonia. The ratio will be 3:1. So on a normal circumstance, hydrogen gas has to react with what? Nitrogen gas to form what? As in 3 moles of hydrogen gas will react with 1 mole of what? Nitrogen gas to form what? 2 moles of what? Ammonia. I hope you understand what I mean by this. I hope you understand. So this is what we call stoichiometry. The mole ratio to which what? Reactants do what? Combine to form what? Products. That's what I mean. Now, if I use another reaction, what will be the stoichiometry when I react? That what will be the mole ratio? Do you understand? When I react butane with what? Oxygen. That's combustion of hydrocarbons. When I react with butane with what? Oxygen. Recall, I've done that video. That's when butane, the chemical formula of butane is C4 what? H10. So when you react butane and what? Oxygen, what will be the mole ratio that I talked about, which is stoichiometry. Recall that in combustion, for the faster process, the faster chemical way, that's the chemical formula for writing balanced equation for combustion is given by CSHY plus X plus what? Y over 4O2 to give you XCO2 plus what? Y over 2 H2O. This is the chemical formula to write a balanced equation of combustion of hydrocarbons. Is it clear? Where X refers to this for the first the atom of carbon, then Y refers to the atom of hydrogen. So wherever you see X here, you put 4. Wherever you see Y here, you put 10. Is it clear? Does it make sense? And in combustion, we must get carbon dioxide and what? Water. So write the chemical equation, balanced chemical equation, then tell me the mole ratio of butane to what? Oxygen. Do you understand? I hope you understand very well. Please help this page by liking, commenting, and sharing. Have a nice day. Bye bye.